Terminal 3 will be an incredible 60% bigger than Hong Kong's Chep Lap Kok. Yet they'll have 2 years less construction time. And giant construction projects can lead to giant problems. Building the foundations to this immense structure will be an almighty challenge. Nobody knows whether it can be done, but national pride and Olympic glory is at stake. Foster and partners have won the opportunity to build the biggest airport terminal in the world. Architect Mujan Majidi knows it's an awesome undertaking.
This is perhaps one of the biggest projects any architect has ever taken on board.
Terminal 3 must hold a staggering 150 aircraft at any one time, 120 more than Beijing's existing 2 airport terminals combined.
The scale here is colossal. You know, this is one of the biggest building on the planet.
It's a startling design, but an immense challenge to turn it into a reality. They'll need the best engineers they can find. Mujan Majidi turns to long-standing construction partners, Arab.
The whole system with its quite inherent...
Martin Manning is assigned as their project engineer. He's got overall responsibility for drawing up a construction plan.
In the early stages, there was a great deal of panic because of the program. But as the team got going, there was just generalized hysteria about the amount of work that had to be done.
Manning meets with the Chinese clients to present his schedule. He hopes to start the build in October 2004. The Olympic Games open in only 5 years, and time will be tight. But then their Chinese bosses announce they want to start construction 6 months earlier. Manning is staggered.
When it became absolutely obvious that the deadline was not going to move, your mind gets concentrated pretty clearly about the decisions that you have to take.
Manning's right-hand man, Joe Sumners, has no idea how they'll get the work done on time. But then...
the phone started to ring, and these renowned engineers from around the organisation were sort of picking up the phone and saying, I hear you've got a project, it's impossible delivery time, the engineering is ridiculous, you're bound sure to fail, can I join you?
Construction must start in March 2004, so Sumners and Manning hope to find the site ready and prepared for construction crews to move in. They're in for a big surprise.
When we first drove onto the site, there were still people living in huts.
The T3 site turns out to be a bustling community of 10,000 people. This entire area must be cleared and the population rehoused. This enormous job falls on the shoulders of T3 Vice Commander Madame Xu.
There were 9 villages with up to 10,000 residents sitting right in the middle of this land. And it was really a challenging task to relocate them all.
But Terminal 3 will be important to Olympic success. It takes her several months, but the job is finished just ahead of the official groundbreaking ceremony. Madame Xu is elated.
The first day of construction was on the 28th of March 2004, a really unforgettable day.
They've reached the first major milestone, but a long road still lies ahead. A workforce of 50,000 springs into action.
It was like a scene out of movies. It was like building the pyramids, you know, incredible sight.
Now the construction plans are drawn up, they'll hand over to Chinese firms for the actual build. T3 is so large that it'll take two of China's largest construction firms to do the job. They'll each build one of T3's massive concourses, T3A and T3B. Mr. Bai leads the army of workers at the north side of the site and will take on the enormous responsibility of the construction of T3B.
Anything that goes wrong will make us Beijing people, our construction workers, even we Chinese lose faith. So I do feel a great sense of responsibility.
At the other end of Terminal 3, Mr. Zhang is in charge of T3A.
It is almost unimaginable to complete a project of this scale within 4 years. However, the task is right here in front of you. There's no way through except to do it well.
By April 2004, over 100 excavators arrive on site. 217 pile drivers start knocking 20,000 steel piles into the ground. But they've not drilled far before they encounter a serious problem. The water table here is close to the surface. It can rise even further with heavy rains. The teams need specialist expert advice. One man should be able to help. Professor Ke is an expert on the ground conditions in Beijing.
There are two kinds of piles. One is a pressure-resistant pile, and the other is an uplift pile to prevent the structure from floating due to the high level of underground water. We cannot let the building go afloat when the waters rise.
The piles also help protect the building from the risk of earthquake damage.
When an earthquake wave strikes, it takes some time to travel from the south side to the north side of the building, so we adopted a different design from conventional buildings.
Professor Ke's first concern is to ensure that the joints of these long buildings can stand up to one of nature's deadliest forces.
The joints are seen as more important than building components. Joints must be unbreakable.
Ke knows the joints will come under the greatest strain in the corners of the building if an earthquake strikes.
The corner of the building is affected the most by earthquake waves. This will cause torsion of the building.
Torsion or twisting forces can pose a big challenge to engineers. November 7th, 1940, and the Tacoma Narrows Bridge in the United States starts twisting in the wind. Within minutes, the bridge shakes itself to bits. No human life was lost in this disaster, but similar torsion forces could impact T3 in a quake scenario. If the two ends of the building vibrate in opposite directions, the building could collapse. The death toll could be enormous. T3 will need over 1,000 special joints, absorbing the impact should the roof and walls contort. But this will not be enough. Martin Manning knows the steel beams, or members, must also be designed with safety in mind.